Hello, hello. Can you all hear me?
Yes, sir.
Morning, sir.
Yes, sir.
Okay.
Good, sir.
Good morning. Good morning to all. So uh, we'll start with your thermal stress, and we'll also derive with some of the elastic constant. Okay. So this is given in your first unit. So we'll start this right away. So thermal stresses. So thermal stresses. Thermal stresses are the stresses induced in body due to change in temperature. So suppose that you heat a rod. If you heat a rod or a bar, then so it will obviously expand. But if you resist its expansion or the contraction, then there will be some internal stress developed. There will be a stress developed in the body, which we call it as a thermal stress. So obviously, since it is having thermal term, so some of the terms will come into picture. That is coefficient of linear expansion and rise in temperature. That is delta T, or you may simply say it as T. So thermal stresses are set up in the body when the temperature of body is raised or lowered, and body is not allowed to expand or contract freely. So if you do not allow the body to expand or contract freely, then there will be stresses. But if body is allowed to expand or contract freely, no stresses will be set up in the body. So let us consider the body of length L. T is the rise in the temperature. E is the Young's
सर
modulus. Alpha
सर
is
इट
the.
इज
Please tell.
सर ये फर्स्ट ही स्लाइड में अभी भी है
But क्या हो रहा है?
सर पहला
Black
वाला जो
screen
हेडिंग है
है.
वही
फर्स्ट में है ये
हेडिंग दिख रहा है
अच्छा ब्लैक.
सर किसी किसी का तो
ठीक है ठीक
स्क्रीन
है ठीक है. इसका कुछ और सॉल्यूशन करते हैं. इसको जो है मैं शेयर कर देता हूँ. ठीक है. और तुम लोग ओपन करोगे, स्लाइड नंबर नीचे दिया हुआ है, तो उसी स्लाइड को हम लोग देखते हुए चलेंगे. ठीक है. वेट करो 5 मिनट. यू वेट फॉर 5 मिनट्स. आई विल कम विद अनदर सॉल्यूशन.
ओके सर वो डाउनलोड वाला ऑन कर दीजिए अगर आप सेंड करते हैं तो
Okay, you check your email, college email ID, and open that PPT PDF.
सर आप जो ये पीडीएफ भेजते हैं इसको डाउनलोड करने वाला ऑप्शन ऑफ करके रखा गया है, इसीलिए सर डाउनलोड नहीं किया जा सकता, बस ओपन करके मतलब मेल से
हाँ तो
देखा जा सकता
ठीक है, वो आप जो है उसको अभी रिफर करिए, बाद में मैं इसको इनेबल करूंगा.
है। ओके सर।
So uh, uh, did everybody got this PDF?
Yes, sir.
Yes, sir.
Okay, so we'll start here. So first slide number one. नीचे slide number भी पड़ा हुआ है. You can see there is a slide number mentioned in bottom right corner. So uh, thermal stresses. Thermal stresses are the stresses induced in the body due to change in the temperature, and due to change in temperature, thermal stresses are set up in the body when the temperature of the body is raised or lowered, or body is not allowed to expand or contract freely. But if body is allowed to expand or contract freely, no stresses will be set up in the body. So there will be no stresses set up if you do not allow the body to expand or contract freely. So as we are using the term thermal, so thermal term is always accompanied by some coefficient of linear expansion. We have also delta T, that is rise in temperature. We can denote it simply by using notation T. You can see it in slide number one, that is T, rise in the temperature. And there is one term, that is delta L. Obviously, because of the temperature gradient, we will have extension of the rod due to rise in temperature or contraction of the rod. So moving on to our next slide, that is slide number two. Slide number two, you come to slide number two. So we have thermal stresses in the body, because of which we can see that a change in length is there, that is denoted by delta L. Delta L, and if you have a change in length, then according to our strain, we denote let us denote it by small e. We may always use epsilon term. Let us denote here by small e, and it is this extension prevented upon original length. So extension prevented is something called as delta L, and L is the original length, and this is equal to alpha T or alpha delta T. We are simply writing as alpha T. So thermal stress is equal to this. We know stress is equal to Young's modulus into your this strain. So thermal stress is obviously going to be equal to alpha T into Young's modulus. So thermal stresses is known as temperature stress, and thermal strain are also known as temperature strains. So we will solve some numerical before this. So you can see here this a rod of length. So you please try it on your own first. Obviously you have the solution, but you please try it on your own. Then things or concept will be more clear. So a rod of length is 2 meter long at a temperature of 10 degrees centigrade. Find the expansion of the rod when temperature rises, that is delta T is given to you here, that is temperature has been raised from 10 degree to 80 degree. If this expansion is prevented, find the stress induced in the material of the rod. The given values are the Young's modulus as 1 into 10 raised to the power 5. Alpha is given to you, coefficient of linear expansion. This is something given to you. So what we need to calculate is the expansion in the rod. So you try it on your own. Obviously, means you have the solution, but I request first you try it on your own. This is given in your slide number 3. So you please try it on your own first. 84 means, Ramotag? Okay. So this is we need to calculate the this expansion in the rod of the rod. By mistake, the rod or something has been written. So let us see this. So given to us is length of the rod, that is 200 centimeter. Temperature T1 is given to us is 10 degree centigrade. Final temperature is given to us 80 degree. So rise in temperature, we can calculate it to be as 70 degree centigrade. And we have the value of Young's modulus as 10 raised to power 11 Newton per meter square. And we have been given the value of coefficient of linear expansion, which is denoted by alpha here. So expansion, we all can calculate it uh, using previous expression. That is delta L will come out to be using this expression alpha delta T into L, which will come out to be 0.168 centimeter. And next part of the question is to calculate the stresses. So we'll simply multiply this expression with the corresponding Young's modulus, and which will turn out to be 84 into 10 raised to power 6. So you please try it on your own. You have the solution, that's good, but please try it on your own. So first part was to calculate this expansion. If stresses was not asked, then you may calculate this will be the motto what we are studying in this heading. Under this heading, we are studying thermal stresses. So you can calculate the value of thermal stresses, which will come out to be 84 Newton per mm square. So we all know the value of Poisson's ratio. This is given in your this first unit. We will have a quick recap of this. What is this Poisson's ratio? And based on this, we will try to solve some numericals. So the ratio of lateral strain to longitudinal strain is constant for the given material. When material is stressed within elastic limit, the ratio is called as Poisson's ratio and is generally denoted by mu. So you denote this Poisson's ratio by mu, sometimes nu, or maybe some other terms, but these are the common notations, that is mu and mu. So as the definition says, that mu is equal to lateral strain upon longitudinal strain. So obviously lateral strain will be accompanied by some negative sign here, because lateral strain is opposite to behavior of your longitudinal strain. If you have a elongation, then there will be contraction in corresponding directions, and if you have contraction in the longitudinal direction, then there will be obviously these expansion in mutual perpendicular directions. So we use a minus negative term for this. So let us quickly jump on to some numericals. So determine the change in length, breadth, and thickness. So you have been asked all the three things here: change in length, breadth, and thickness of steel bar, which is 4 meter long and 30 mm wide and 200 mm thick, is subjected to an axial pull of 300 kilonewton in direction of its length. So along 4 meter, a load has been applied and it is pull. So it is a pull of 30 kilonewton, and we have to determine the change in length, breadth, and thickness of steel bar. And the values of this value of Young's modulus is given to us is 2 into 10 raised to power 5 Newton per mm square, and Poisson's ratio is given to us as 0.3. So we have to determine change in length, breadth, and thickness. So can you work out for this solution for this problem? So please do it on your own. You try it on your own. That depends on obviously on you. If you are trying on your own, then you will obviously learn many things. But if you are simply looking at the solution, then this will not result into beneficial for you. So you try it on your own and determine the change in length, breadth, and thickness of a steel bar. Okay. Normal premium shoe. So that's good. You have tried. Rest of the people try it on your own. Somil, please ask.
सॉरी सर वो gently
ठीक है कोई प्रॉब्लम नहीं. Okay, so let us look for the solution for this. So these are the answers, and we will straight away look for the solution. Length of bar is given to us is 400 mm. Breadth is given to us 30 mm. Thickness is given to us is 20 mm. So obviously we can calculate the area of cross section. This comes out to be 600 mm square. Load applied is given to us as 30,000 Newton, and Young's modulus 2 into 10 raised to power 5 Newton per mm square. Poisson's ratio is given to us as 0.3. So now strain in direction of load or longitudinal strain. This will we can calculate it as P by AE, which comes out to be 0.0025. So once you have the strain, we know the length. We can obviously calculate the change in length, which comes out to be 1 mm. So this is in the slide number 7. So change in length is 1 mm. So through this, we can calculate the lateral strain by using corresponding value of Poisson's ratio, which comes out to be 0.000075. So this is a dimensionless quantity. So sorry, this one, lateral strain. So this is strain. So once you have the strain value, you multiply it with by corresponding thickness, you will have the value of your change in thickness, which will be yes the 0.0015 mm, and the change in width will be equal to 0.0025 mm. So we were asked three things: change in length, change in thickness, and change in breadth. So how did we approach to the problem? We calculated the change in length by using our this simple expression, using this your formula P upon AE. So from there we calculated this change in length. So using the strain, longitudinal strain, and from we calculated two things. We focused on two things, that is longitudinal strain, and second is your lateral strain. So once we know the longitudinal strain and lateral strain, we can determine all the changes in corresponding all the directions which we are asked. That is change in length, change in width, and change in thickness. So so we'll move to your next question given on slide number 9.
हेलो सर।
Please tell.
सर लेटरल स्ट्रेन मिडल में
हाँ
ज़्यादा
बताओ
रहेगा ना पूरा रेड के मुकाबले?
कौन सा?
सर लेटरल स्ट्रेन होता है लॉन्गिट्यूडल स्ट्रेन के कारण पॉइसन रेशियो में, तो
एक
पूरा रेड में
वेट लैटरल स्ट्रेन जो है
लॉन्गिट्यूडनल स्ट्रेन के कारण होता है, तो पूरा रेड में यूनिफॉर्म होता है कि मिडल में ज़्यादा होता है, वैसे टाइप का कुछ होता है?
नहीं, हम तो
कि
यूनिफॉर्म पूरा एज्यूम करते हैं इसमें।
क्योंकि
विद इन इलास्टिक लिमिट हम लोग डिस्कस कर रहे हैं ना टर्म, विद इन द इलास्टिक लिमिट।
ओके सर।
हाँ डिस्टर्बेंस ठीक है, ओके। So we'll move to our next this question, that is question number 9. Okay, so we'll take all the queries once we will end up this class. We will also take all the queries. Okay, so before that we will proceed towards question given in our slide number 9. So this is something determine the value of Young's modulus Poisson's ratio of metallic bar of length is given to us is this 30 centimeter. Breadth is given to us is so we have been asked elastic constant here. That is, E is supposed to be calculated, mu is supposed to be calculated, length is given to us, breadth is given to us, and depth is given to us. So all the dimensions are given. We have been asked elastic constant, that is E and mu. When bar is subjected to an axial compression of 400 kilonewton, decrease in length is given by 0.075 centimeter and increase in breadth is given by 0.003 centimeter. So we have been asked value of Young's modulus and Poisson's ratio. So can anybody? So please solve this. You have the solution. Then what to do in this? So you solve this this question. We have been asked the value of Young's modulus and Poisson's ratio. So yes, sir, there is 10 raised to the 5 Newton per mm². Okay. Okay. So some are giving this answer. So that's very good. You are trying it on your own. This I'm happy to know is this. So please try it on your own first. Mu comes out to be 3 by 10. Okay, 0.3. Okay, e raised to power 11 Newton per the meter square. Okay. Okay, what about this your Young's modulus, Abhijit? Okay, Saurabh has given all the two answers. I guess you are solving it on your own. Please work it out once more. I guess mu will come out to be 0.3. Riyanshu, sorry. Abhijit. Okay. Okay, so I will move to next solution for this. So let us see this. Length is given to us is 30 centimeter, breadth is 4 centimeter. So this is slide number 11. Slide number 11. So length is given to 30 centimeter, breadth is given to us is 4 centimeter, and depth we are given as 4 centimeter. So we can calculate the area of cross section. So this is comes out to be this 16,000 mm². So we have the value of load as 400 kilonewton. Decrease in length is given to us is this point 0.075 centimeter. Increase in breadth is 0.003 centimeter. This is slide number 11. So longitudinal strain will be we have the length, we have the change in length, we can calculate the longitudinal strain, which comes out to be 0.0025, and as well as lateral strain comes out to be 0.0075. So we know that Poisson's ratio is obviously that lateral strain upon longitudinal strain. This comes out to be 0.03. So longitudinal strain will be equal to your we know that from using this expression longitudinal upon stresses in stresses, we can calculate the value of your this Young's modulus, which comes out to be 1 into 10 raised to power 5 Newton per Newton mm². So next part of question. Yeah, we have calculated both the parts. That is Poisson's ratio is 0.03, and Young's modulus as 1 into 10 raised to power 5 Newton per mm². So moving out on to next part, to volumetric strain. So now we will have some these terms. Gradually, we proceed towards your bulk modulus. Before understanding the bulk modulus, we need to understand what is your volumetric strain. Please come on to slide number 12, volumetric strain, slide number 12. So the ratio of change of volume to original volume of body. So that is ratio of change of as the term strain is suggesting that in numerator we will have a change and denominator will be original. So for the volumetric strain, the similar sense also meaning applies. That is ratio of change in volume to original volume when body is subjected to a single force or system of force is called volumetric strain. It is denoted by EV because we are using the term volumetric. So mathematically, this can be expressed by equation number 5. Equation number 5, we can see that EV is equal to delta V upon V. So we are familiar with delta V and V. So now we are going to derive one expression where we have this term this subjected to an axial load P in direction of its length. Okay, so there is some this axial load in direction of its length. So this is change in length, and delta V denotes the change in width, and delta D change in depth. So we know that original volume is given by L B D. Final volume is given by this L plus del L, B plus del B, and all the del terms will be accompanied. So change in volume is nothing but final volume upon original volume, and this turns out to be this del L upon L, del B upon B, and this delta D upon D. So if there is equal volumetric strain in lateral direction, so longitudinal direction means along the length, lateral perpendicular to the length. So if there are equal extension as well, equal contraction in both the directions, so we will have lateral strain of equal magnitude. So that's why we made the term del B upon B is equal to del D upon D. And once you have this, we will substitute the value and taking care of negative sign. So once we have all these values, so we can work out a volumetric strain, that is del L upon L 1 minus 2 mu, which is given by expression 12. So this is the case when we have a direct stress, that is direct load in along this length direction only. We have a load along the length direction, then there will be a volumetric strain, that is del L upon L 1 minus 2 mu. So we have only one load that is acting along the length. Then this value of EV, that is volumetric strain, is del L upon L 1 minus 2 mu. So we'll come to numerical given on your slide number 15. Please work out for this numerical. Okay, so length of bar is given to us is 4 meter, width is given to be 30 mm, thickness is given to us is 20 mm. It is subjected to an axial pull of 30 kilonewton. So only single load is applied in along its length, that is of 30 kilonewton in direction of its length. Young's modulus is given to us is 2 into 10 raised to power 5 Newton per mm square, and Poisson's ratio is given to us is 0.3. Determine the volumetric strain. So we have to determine the volumetric strain. So these are we can calculate the original volume. So once we know the original volume, so we have been given the value of your so longitudinal strain will come out to be this value point this 005, and using the expression this expression number 12 given on in your slide number 12 14. Once we know the longitudinal strain, that is delta L upon L, once we have this value, we can calculate the volumetric strain. But this case is only valid when a bar is subjected this bar is subjected to this load in your axial direction only in axial direction. Then our formula given in expression number 12, equation number 12 is valid only for bar subjected to load in your axial direction only. So
सर
moving on to
इक्वेशन
बताइए
सर इक्वेशन 6 यहाँ पे लागू नहीं होगी क्या?
equation number 6 wait I'll move to we'll take your query let me complete another question, then I'll wind up the class, then we'll take all the queries. Okay, wait for some time, then we'll take all the queries after this class is over. So you move to slide number 18, and you move to slide number 18 and please solve this question. Steel bar 300 mm long, width is given to us is 50 mm, and thickness is given to us 40 mm, is subjected to a pull of 300 kilonewton in direction of its length. So only in direction of length we have been given this 300 kilonewton is acting along its length. So we have to determine the change in volume. So change in volume need to be calculated. Value of Young's modulus is 2 into 10 raised to power 5, and mu is given to us as 0.25. So determine the change in volume. So you please work out on this question. Slide number 18, you please work out on this question. Okay, so all the dimensions are given. Load is acting along the length, and value of elastic constant is given to us. So we have to determine the change in volume. So let us proceed for this. So these are the given value. We can calculate the longitudinal strain, and once we know the longitudinal strain, and we can calculate since it comes out to be 0.00075 longitudinal strain. So once you have value of this longitudinal strain, so obviously using this expression, EV is equal to delta L upon L 1 minus 2 mu. We can calculate the change in volume. It comes out to be 225 mm cube. Okay, so this is the calculation of volumetric strain. So further we will look into this Young's modulus and try to derive the relation between bulk modulus. We will try to derive the relationship between different elastic constant in our this next class. So with this we'll stop here, and people who need to discuss something will stay, and remaining may please, if you do not have doubt, you may please leave. We'll stop here. So I'll wait for 5 minutes, then we will take all the queries.
Sir, the answer comes out to be 2250.
Answer comes out to be
2250.
so if you multiply this will come out to the 2250. So you please recheck your calculation. You recheck your calculation, but I think that this answer given in your slide number 21 is correct. Ramavatar, you are listening now?
Yes, sir.
So you relook into your calculation.
सर अगर क्रॉस सेक्शन ट्रायंगुलर हो तो फिर
हाँ।
लैटरल स्ट्रेन कैसे लेंगे?
ट्रायंगुलर तुम ट्राई करो एक बार आयुष इसको इसका
इससे तो ये क्या मतलब जो सेंट्रोइड से डिस्टेंस आएगा उस हिसाब से लेंगे?
वो ऐसे नहीं होगा ना, वो तो अनसिमेट्रिकल सेक्शन हो गया। अभी तो हम लोग सिमेट्रिकल का केसेस डील कर रहे हैं। तो अनसिमेट्रिकल सेक्शन तुमको अभी बाद में ये हम लोग डील कर कुछ क्लासेस में जो है उसको वो भी पढ़ाया जाएगा। अनसिमेट्रिकल सेक्शन उसका सिमेट्री नहीं है क्रॉस सेक्शन का।
यस सर ओके सर।
सर एरिया कौन सा वाला लिया जाता है, जैसे
क्रॉस सेक्शन वाला, क्रॉस सेक्शन एरिया
जिस पर फोर्स लग रहा है वो?
हाँ क्रॉस सेक्शन तो वही हुआ ना।
Okay, sir. Thank you, sir.
Okay, Ramta, you were discussing something.
No, sir, I got it.
Okay, that's fine. So if there are no further queries, then I'll end this class here.
Sir, excuse me, sir.
Yeah, please tell Avantika.
Sir, approximately mid sem में कहाँ तक आएगा?
Mid sem में we have not decided yet, but means it will be not that much that you will be not means able to बहुत ज़्यादा नहीं burden होगा, approximately proportionate में divide होगा, ठीक है? I have not decided yet, but
सर फिर भी किसी लास्ट टॉपिक का नाम जो
ये
हो सकता है।
यूनिट में कवर करने का सोच रहा हूँ इसको।
सर इम्पैक्ट
तो
लोडिंग का।
Pardon, I can't get you.
सर इस यूनिट में लास्ट इम्पैक्ट लोडिंग है ना?
हाँ, इम्पैक्ट लोडिंग तक मैं कवर करने का सोच रहा हूँ। Mid semester is you're on this October, no, 4th of October it is going to start, na?
Yes, sir.
Okay, so after mid semester we won't have time because you have even break for something 1 week. So after the portion which we will be covering here in your prior to mid semester is what something very much useful, because after that we will not get more lectures.
Okay, sir.
Okay, I'll end the class.
Sir,
please tell Ankit.
सर क्वेश्चन में लेंथ 300 दिया है मगर आंसर में लेंथ 3000 दे रहा है, उससे 250 आ रहा था।
हाँ, तो इसलिए शायद this Namorta is getting 2250. I'll look this. The question you have given this 300 mm. Oh, okay. While solving, so you take it as this 300 mm. Okay.
Okay, sir.
Okay, thanks everyone. So I'll end the class here. If there are more queries, then you can please ask. Then I'm going to end the class.
Sir, in syllabus, sir, reference
Krishna,
book,
please tell.
sir,
Please
reference
tell.
book, sir,
Yes.
reference book 4 दिया हुआ है sir. Can you suggest any one, sir, that we can buy?
टिमोशेंको तो दिया है तुमको वो PDF बाई कुछ नहीं करना है. Everything you will get free on internet. You need not to buy anything. You will get all things this.
Okay, sir.
Yes.